Peter here with a quick little video demonstrating a couple features of the PDP-12, the do button, which does one instruction, and the rotate instruction, which rotates data from the accumulator into the multiplier quotient and also back into the accumulator. So let's start with the do instruction. So the first thing, or the do button, so if I set the left switches to 2000, that's going to load the contents of the memory specified here into the accumulator. And I don't really know what's here, it doesn't really matter, but when I push the do button, you see that I've loaded the accumulator with some data that's come out of memory. So if I do IO preset, I'm going to clear the accumulator. If I hit do again, I'm going to copy that data back in from memory. Okay. So now one of the things we're interested in is does the multiplier quotient hold bits? Does it set them correctly? Does it do what it's supposed to do? And there's an instruction in the LINC side of the CPU called rotate that rotates out of the accumulator and into the MQ, the multiplier quotient, and also into the accumulator. So if we look at the manual here, this is from the PDP-12 system reference manual that we've reprinted from BitSavers. Thanks, BitSavers. You'll see that the instruction is 3000 plus the essentially the number of bits that you want to shift, or I'm sorry, the number of places you want to shift. And so what we're going to do is shift bits. They're going to shift right out of the accumulator back into the accumulator, okay? But they're also going to shift at the same time out of the accumulator and into the multiplier quotient. And then anything that's shifted off of the multiplier quotient goes into the bit bucket. Okay, so what we should be able to do is use this to test whether we can shift data out of the AC into the multiplier quotient and then out. Okay, so going back here, we did the do instruction, so I'll do that again. So here's 2000. I'll do. We're going to copy this data in. Okay, if let's see, I do IO preset, but we can copy data from a different memory address. Okay, so I'll do that, and we've got some different data here. Okay, I'm going to go back to this because it works better for our demo. So IO preset, do, so we have this bit pattern here. What is that? 6041. Okay, so now I'm going to change the instruction to be 30001. Okay, and what that's doing is that's the rotate instruction, and I've said I want to right shift one bit at a time out of the AC, back into the AC, and into the multiplier quotient. So what we should see is these bits moving, so let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we see that the shift appears to work correctly. So let's load that other data. So 2777, we're going to IO preset, we'll do it. So now we'll do it. So we have this address here. So do increments the instruction, I believe. So I think that's why it was changing. Okay. So IO preset do. So we've loaded this in here. Now we're going to switch back and we'll do that right shift again, 3000. Okay, so I'm going to shift 1, 2. Oh, I forgot to how many bits to shift. IO preset. Let's load this again. 2777. Do. Okay, now 3001. So now we're going to shift this 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and so we're back where we started. So it appears that this rotate is working correctly, and we're able to move bits from the AC into the MQ. Let's do this again. This will be a 2000 from a different location. So what do we have here? 0736. Is that right? 0736. Okay, so now if I go and I do the shift 1 bit and I do this 12 times, we should get 0736 in the multiplier quotient. So here goes nothing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 0736. Okay, so that convinces me that the rotate function is working, and that incidentally all the bits in the multiplier quotient are changing the way they're supposed to, at least for a test like this. So that's kind of fun. Thanks for watching.